Hey guys, I hope that you would be doing well. In today's video, we are going to solve and we are going to find continuity of another function at a given point. Okay, in the previous video, we have solved a question in which we found continuity of a function at a given point, and now we are doing the same for this question. Okay, so the question is this is a compound function. Okay, f of x equals f of x equals 1 plus x. Okay, so when x is less than 1, this is one equation. The next one says 5 minus x when x is greater than or equal to 1, and I have to find the continuity of this function at x equals 1, and I have to find the continuity of this given function of this function at this given point, which is x equals 1. Okay, so in the previous video, I've already told you that there are three steps to find continuity of any function. So the first step is to find that is the function defined at this point. Okay, that the given point is x equals 1. So we have to check that the given function f of x is it defined at x equals 1. So let's do this. Okay, so that this is the first step. Okay, so when x equals 1, when x equals 1, as you can see in the given function, this is the compound function because there are two equations in this given function. As you can see that when x is greater than or equal to 1, so it means that when x is equal to 1, the function is 5 minus x. Okay, the given function is 5 minus x. So f of x is equal to 5 minus x. So put x equals 1. So if I put x equals 1, so f of x would be 5 minus 1 is 4. So this is defined because 4 is a real number. 4 is a real number and this is defined. Okay, now let's move to the second step. The second step was to find that the limit, does the limit exist at this point, at x equals 1. I have to find the limit at this point. Okay, so let's do this. Let's find the limit of the given function at the given point. Okay, which is x equals 1. So limit limit x tends to 1 f of x. As I already told you that when x approaches 1 or x tends to 1 means that the x is not exactly 1. Okay, x is very close to 1 either from the left side or from the right side, but this is not exactly 1. So you would be confused that what function should I take? This is 1 plus x. This x is not equal to 1. 5 minus x. There you can see that there are two options, greater or equal. So x is greater than 1. So it means that in both equations, in both functions, okay, this is a compound function, in both equations, the x is not equal to 1. So which function should I take? So here comes the concept of right hand limit and left hand limit. Okay, so here I will find right hand limit and left hand limit. Okay, so first I am going to find right hand limit. Right hand limit. Okay, or HL mean right hand limit. Okay, don't be confused. So right hand limit, what does right hand limit mean? Okay, when when a constant which is 1, yeah, I would say that yeah, when x, okay, when x approaches 1 or to the constant from the right side, let me draw a real number line so you will understand it better. This is 1. Okay, this is 1, and we've already talked about limits that the x is not exactly 1. Okay, this is not exactly 1, this is very close to 1. So from which side, from right side or from left side? So right hand limit mean that when the x, okay, the x approaches 1 from the right side, from this side. So I can say that the x is very close to 1 right over here, right over here from the right side. Okay, from the right side, or it may be more close to the to the 1. Okay, so this is the limit approaching from the right side. Okay, so as you can see here, the x is greater than 1. Okay, the x is greater than 1 because it is approaching from the right side, so as you can see from the number line, because this is positive and this is negative, I would say, yeah, just forget about the positive and negative. As you can see that the limit approaching the x approaching the 1 from the right side, so from the right means that the x is greater than 1. Okay, so limit x tends to 1, and this plus means that the x is approaching from the right side. Okay, it doesn't mean that x is approaching to positive 1. Okay, it does not mean that. It means that the x is approaching 1 from right hand side. So as I already told you that in this case the x is greater than 1, so come here and these both equations, which one the x is greater than 1. So in this one, 5 minus x, here you can see that x is equal or greater than 1. Okay, so I would take 5 minus x. So now I apply limit. So when I apply limit, the final answer is, when I apply limit, so 5 minus 1 is 4. 5 minus 1 is 4. So this was the right hand limit. Now let's find left hand limit. Okay, left hand limit mean, let's again come to the number line. Left hand limit mean when x approaches 1 from the left hand side, from this side. Okay, from this side. So when the x approaching, when the x is approaching 1 or any other constant from the left side, so it means that this is left hand limit. In this case, as you can see, the x, okay, the x variable it is less from the 1 because it is on the left side. So let's come over here. Limit x tends to 1 from the left side. The negative sign mean that the x is approaching 1 from the left side. Okay, the positive sign meant that the x is approaching 1 from the right hand side, and the negative sign mean that the x is approaching 1 from the left hand side. It doesn't mean that x is approaching minus 1. Okay, don't be confused. So it means that x is less than 1. So come to the equation, come to the function. In these two equation, which one the x is less than 1? So in this one, this is the case when x is less than 1. So let's do this. So I would say 1 plus x. Now if I apply limit, the final answer is 1 plus 1 is 2. 1 plus 1 is 2. So what does it mean? Does the limit exist or not? Not. Why? You would say why? Because both are real number. Why can't it be true? So let me tell you, when the left hand limit and the right hand limit, they both are not equal, is in this case, so it means that the limit does not exist. In this case, as you can see, that the right hand limit is not equal to left hand limit. So the function does not, the limit, sorry, the limit does not exist. So we failed in the second step. The first step was true, it was defined, but the second step is not true. The limit is not defined. The limit does not exist. Sorry, the limit does not exist. So it means that the function, this given function, it is not continuous at this x equals 1 point. And you can also draw graph. In the graph, you will definitely see that there is a great hole in between 1 plus x and 5 minus x. There is a great gap between these two equations of the given function. So this is not continuous at this given point. Okay, at x equals 1, it is not continuous. So this is for today. All you have to do is practice, because it requires a lot of practice, and if you do practice, I hope that you'll be able to solve many more questions. Okay, when you practice a lot and when you work hard, the maths is then easy. Okay, so all I want from you is to subscribe this channel because I need your support a lot. If you do support me, I will be able to make more videos. So until then, until next video, goodbye.